Okay, so this is the review for the second part of the test review on our trig identity unit. It starts with filling in the blanks. So let's look at our identities. So cosine squared minus sine squared is right here, cosine 2 theta. 1 minus 2 sine squared, right here, also cosine 2 theta. And 2 cosine squared theta minus 1, same identity, cosine 2 theta. 2 times sine times cosine is sine of 2 theta. Sine alpha over 1 plus cosine alpha. That's not here. At least not anywhere that I see it. So let me jump to one that I can see. Down here, the 1 plus cosine alpha over 2 is cosine of, oh, I gotta make it an alpha. Alpha over 2. And then let's figure out the others. Oh, 2 tangent. We'll see how tangent of alpha plus beta, if I made them all the same alpha, like tangent of alpha, alpha plus alpha, then on the numerator, I'd get 2 tangent alphas and 1 minus tangent squared. So that is this identity right here. So that is tangent of 2u, because they're using u. So let's see if I can figure that out. Oh, g, that matches exactly with tangent of alpha plus beta. And then let's figure out e and go back to that one. Sine over 1 plus cosine. Well, I'm kind of stumped. It's not on my formula sheet, and I haven't taught the unit yet because I'm doing all the videos before we've gotten there to prepare. And I don't remember where that's going to come from. If it occurs to me while I'm going through the video later, I will do it. Oh, I know what to do. See, nobody's perfect. Teachers need a moment too. I'm going to multiply. Let's see if my gut instinct is right. To simplify it, if I multiply by the conjugate, the denominator is going to be 1 minus cosine squared. And then that is the same as sine squared. So I can simplify to that fraction. Then is that on my formula sheet? No. So I'm just going to put that as my answer. Okay. Use a sum or difference identity to get the exact value for number 2. So 285. I have to think of that as a sum or difference of 2 angles that I already know. So let's see, 285. I know it says no calculator, but I'm going to use it for my arithmetic. If I subtract that from 360, nope, that's not going to help me. Oh, isn't it 245 plus 4? Oh, no. I'm going to do 240 plus 40. 240 plus 45. Because it ends in a 5. I know my one special angle has to be 45. So 240 would fill that out. Then I'm going to use the sine sum identity from here. to expand this, so it's sine, cosine, same, cosine, sine. And you have the formula sheet, so you can just make sure you're filling that in the right spots. So now sine of 240, well, sine has a reference angle, well, I'm sorry, 240 has a reference angle of 60. So sine of 60 is root 3 over 2. But it's going to be negative because 240 is in the third quadrant. Cosine of 45 is root 2 over 2. Sine of 45 is the same. Now cosine of 60, the reference angle of 60 is 1/2. But in the third quadrant it's negative because 240 puts you here. All students take calculus. It's 60 degrees past 180. So we get negative root 6 over 2 plus negative root 2 over... Oh, no, 2 times 2 is 4 in the denominator. Sorry about that. So that's negative root 6 minus root 2 all over 4. All right, for cosine, for part B, it says cosine of 7 pi over 12. So I actually like radians better than the degrees because I know to get a common denominator of 12, I need 4 and 3 because 4 times 3 is 12. So if I'm going to add up to get 7, like if I did 3 pi plus 4 pi, that's going to get me 7/12. So that's pi over 4 and pi over 3 because if I reduce 3/12 is 1/4 and 4/12 is 1/3. So now I can do cosine, cosine change, sine, sine. Cosine of pi over 4 is root 2 over 2, and so is sine. And then pi over 3 is 60. So pi over 3 cosine is 1/2, because these are all in the first quadrant, which is nice. And then sine of pi over 3 is root 3 over 2. So we get root 2 over 4 minus root 6 over 4, which is root 2 minus root 6, all divided by 4. Okay, and C says tangent of 17 pi over 12. So let's see. If I want to get over 12, what two numbers add up to 17 that can reduce by 12? I could try 15 and 2. So let's see, 15/12 and 2/12 this would be 1/6, and then 15, they both divide by 3, so 5/4. So let's do that. Tangent of 5 pi over 4 plus pi over 6 would equal 17 pi over 12. Okay, so the tangent identity is here. So that gives me tangent 5 pi over 4 plus tangent of pi over 6 divided by 1 minus tangent of 5 pi over 4 times tangent of pi over 6. Okay, tangent of 5 pi over 4. Tangent of pi over 4 is 1. 5/4 is in the third quadrant, so that's positive 1. Tangent of pi over 6, here's pi over 6. Tangent is opposite over adjacent. So let's make that 1 plus 1 over root 3, all divided by 1 minus 1 over root 3. All right, number 2's done. On to number 3. If cosine is 12 over 13 and theta's in the fourth quadrant, so adjacent over hypotenuse, find those. All right, well, first I need this y value. It's negative because we go down. Pythagorean theorem. 12 squared plus y squared is 13 squared. So that is going to be -5. Sine of 2 theta with the identity is 2 sine theta cosine theta from here. So I just need the sine and cosine ratios from this picture. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So when I multiply these together, 2 times 5 times 12 is negative 120 over 169. Of course, I don't have enough space there. Let's do B. Cosine of 2 theta. Well, you have your choice on identities. I'll just do the first one. Cosine squared minus sine squared. So the cosine ratio from the picture is 12/13. The sine is negative 5/13. So I will square each numerator and denominator. To get my final answer. Of 119 over 169. So then C says tangent of 2 theta. That's not on your formula sheet. But that's okay, because tangent is sine divided by cosine. And guess what? We already have those answers. Sine is negative 120 over 169. Cosine is 119 over 169. So to simplify this, I take my numerator, multiply by the reciprocal of the denominator. So we get negative 120 over 119. And C. Oh, same kind of problems. All right. We need a new picture. Sine of theta is positive, so that's here and here. And tangent is negative, that has to be the second quadrant. Tangent is opposite over adjacent, and because we're to the left, the 7 is the negative component. So figuring out the hypotenuse with Pythagorean theorem, it will be 25. So then for all of these, use the same process we did for 3. All the answers are on the last page on 67, and you can check them. Oh, that was silly. Why didn't I do that for 1e? Tangent of alpha over 2. So that's not, oh, sine divided by cosine, Miss Weiss. If I do sine divided by cosine, we would get to here. Okay. Half angle identities. $157.5. So let's see, that times 2 is 315. So A is sine of 315 divided by 2. Using the sine half angle. 1 minus cosine of 315 over 2. Sorry about that. Okay, so then cosine of 315 is a reference angle of 45 in the 4th quadrant. So then to simplify this, I'm going to make this one 2 over 2. So my numerator is 2 minus root 2 over 2. And then instead of divided by 2, I'm going to multiply by a half. So that's a big square root of 2 minus root 2 all over 4. And then the square root of 4, I can simplify so that the radical is only in the numerator, and then the denominator is just 2. All right, B, cosine of 7 pi over 12. I want to know what is that divided by 2. So if I multiply by 2, that reduces to 7 pi over 6. So using the cosine identity, it's going to be 1 plus cosine of 7 pi over 6 all over 2 here. And then to simplify, all right, 7 pi over 6. Well, here's my special angle triangle. So cosine is root 3 over 2. But then 7 over 6 pi is in the third quadrant, so that's a negative root 3 over 2. So let's see, to simplify that, I'm going to make this a 2 over 2. So we get 2 minus root 3 all over 2 times a half, because of this is the reciprocal of that denominator. So then 2 times 2 in the denominator is 4. The square root of 4 is 2. And I'm just left with the radical in the numerator. And then tangent of pi over 12, this was b, so c. That's the same thing as tangent of pi over 6 over 2, because if I take that times 2, pi over 12 times 2 reduces to pi over 6. And we didn't have the tangent half angle on the formula sheet. So we could either go back to the problem I did not know how to do in number 1. Bing. So that is sine of pi over 6 divided by 1 plus cosine of pi over 6. And then, where's my special triangles? Pi over 6 sine is 1/2. Cosine is going to be root 3 over 2. And then we get in the denominator, so this is 2 over 2, so that's 2 plus root 3 all over 2, multiplied by the reciprocal. And there's our final answer. Oh, that doesn't match the answer sheet because we don't leave a square root in the denominator. So I can multiply by the conjugate to fix that. So that gives me 2 minus root 3 all over 4 minus 3, oh, which is 1. So 2 times 2 is 4. Root 3 times negative root 3 is negative 3. There's the 1. Okay. Whew, that's number 5. Number 6. Draw the pictures. Cosine is positive here and here. Sine is negative, so that has to be the fourth quadrant. Opposite over hypotenuse. To find the missing side, that's going to be 5. So then for A, sine of theta over 2 is the square root of 1 minus cosine theta over 2. So 1 minus cosine from this picture is 5/13. So the 1 I'll make 13 over 13. 13 minus 5. And then we're going to have the, where was I? Sorry, I lost my train of thought. 13 minus 5 is 8. Don't like it like that, so I'm going to make it 8 over 13 times a half. These reduce to 4, so we get the square root of 4 over the square root of 13, which is 2 over the square root of 13, but we don't leave a square root in the denominator. So we get 2 root 13 over 13. Whew. Okay, B, cosine of theta over 2 is 1 plus cosine theta divided by 2. Cosine from that picture is 5/12 again, or 5/13. Oh, so it's going to be the same. This will be 13 over 13, but now 13 plus 5 is 18/13 times a half. So we get the square root of 9 divided by the square root of 13, because this reduces, which gives me 3 over root 13, which where, if we rationalize, we get 3 root 13ths over 13. Whew. And then tangent is sine divided by cosine to get the tangent answer. Yikes. And I just realized what I've been forgetting since the beginning is the plus or minus, and how to know which one to use. So in the B, these all should have been negative because if we do theta divided by 2, it's going to move the quadrant into a cosine negative quadrant, and the sign was positive because when we divide by 2, it'll put us over here where the sign is positive. So that's why A is positive and B is negative. Okay, and for 7. Oh man, there's a lot of problems there. We got to match the identities. So 2 cosine squared angle is here. So that goes back to cosine 2 theta. So that's cosine of pi over 4, which is root 2 over 2. If you still do not know your unit circle or the special values, get with it. See your teacher at lunch, find something on YouTube, but let's go. Unit circle is going to keep coming up over and over and over and over again. Okay, B, sine over 1 plus cosine. From number 1 was the tangent identity. So this is tangent of 3 pi over 2, because it's this 3 pi half. All right, tangent of 3 pi over 2 is from down here. Tangent is y over x, that is undefined. This identity, cosine 1 plus cosine in the numerator, is the cosine half angle. So that's the same thing for cosine of 210. So 210 is in this quadrant, 30 degrees past 180. So that's going to be a negative answer. Go back to the very beginning with my special triangles. Cosine is root 3 over 2 for the 30 degrees. Cosine squared minus sine squared. Where is that? Oh, here we go. Cosine 2 theta. So that is cosine of 2 times 75, which is cosine of 150. So 150 is a reference angle of 30, but in the second quadrant, so also negative root 3 over 2. E, this identity, the double angle for tangent. So that is tangent of 2 times 11 pi over 12. So the 2 and 12 reduce, that's 11 pi over 6. So that is almost 2 pi in the fourth quadrant, and in the fourth quadrant, tangent is negative. Tangent of pi over 6 is opposite over adjacent. Then we get negative 1 over root 3. F, 2 sine cosine is my sine double angle. Oops, sine 2 times 67.5. So that is sine 67.5. I'm pretty sure on your test you're going to be able to use a calculator the entire time, especially for the arithmetic like that. I mean, you'll have to give these exact values, so the calculator does not really help. 135 is 45 less than 180. So sine of 135 is root 2 over 2. In the second quadrant, positive. Last one. 1 minus 2 sine squared is cosine, 1 minus 2 sine squared is cosine 2 theta. So that is cosine of 5 pi over 4, which is root 2 over 2, but 5/4 is a little more than 1, so negative because we're in the third quadrant. In the home stretch, some solving. All right, for A, get some more paper. Cosine 2x minus cosine x. So using my identities, I'm going to stick with all cosines. So I'm going to do 2 cosine squared x minus 1. Now, this is a quadratic, but out of standard form, so I'm going to reorganize it so I can factor. So to factor this, I'm going to imagine a quadratic without cosines. I like box method. You could split the middle. You could just guess and check. 2 times -1 is -2. The only way to get that is to multiply 1 and 2, but I want to add to -1, so the 2 has to be negative. So in my box to factor, I'm going to do 1w and -2w. So with the 1 here, this has to be 1 and 1, but this has to be negative to make that row negative. So the 2w must go here and the w must go there. That checks out. So this factors to 2 cosine x plus 1 and cosine x minus 1, because each w was cosine instead. I'm going to set each factor equal to 0. And because we have 8 solving questions, I'm going to draw my special triangles so that I can have a nice, clean drawing to refer to. Okay. When is cosine -1/2? Cosine is negative in these two quadrants, giving me an adjacent over hypotenuse of 1/2 would be pi over 3 as a reference angle. So to be in these two quadrants is going to be a little less than 1 and a little more than 1, because 3 over 3 is 1. And then when is cosine +1? It's the x-coordinate. That happens at 0. And looking at my directions, I include 0 and not 2 pi. So there we go, 0. Okay, 1 down, 7 more to solve. Sine of 2x. The only way, the only identity for that is 2 sine x cosine x. And then I actually have a greatest common factor of 2 sine x to factor out. Set each factor equal to 0. Divide by 2. Add the 1. So I already solved this. So when is sine 0? It's the y coordinate, and that happens at 0 and pi. Oh, that one wasn't too bad. All right, C is cosine 2x plus sine x. So there's 3 choices for the cosine 2x, but I want to stick with all sines. So I'm going to make this 1 minus 2 sine squared. And when I factor, I don't like the negative coefficient in front of the squared term. So I'm going to take all of these and move them to the other side. So that'll be positive 2 sine squared, negative sine x, and then negative 1. Oops, I already have equals 0. So it's the same kind of factoring we had up here. 2 sine squared minus sine. 2 sine squared minus sine. So I'm going to make that 2 sine x plus 1, sine x minus 1. Same thing but with cosines. Set each factor equal to 0. Isolate the sine. And go to my pictures. So let's do sine of 1 first. Sine is the y coordinate. It is positive 1 up here at pi over 2. The other, I want opposite over hypotenuse to be 1/2. So opposite the 1 is pi over 6. And those are going to be my reference angles because sine is negative in the 3rd and 4th quadrant. So a little more than 1, so 7/6, and a little less than 2. So if you think of in terms of 6th, 12 over 6 is 2 pi, 6 over 6 is 1 pi, so here's my 7 and 11. All right, on to D. Huh, that's unique. Okay, sine of 4x is not one of my identities. Sine of 2x is, but I'm going to think of 4x as 2 of 2x. So I'll think of that as like 2 beta. So that's 2 sine beta cosine beta. But instead of beta, it was 2x. So this is going to be plus 2 sine 2x cosine 2x. And I'm going to take this back to sine 2x, because watch what happens. They share one. So I'm going to factor that out. Now I can set each factor equal to 0. When is sine of 2x equals 0? Okay, so I'm going to think, when does sine of theta equal 0? That's when is the y coordinate 0? Well, that's at 0 and pi. So theta is 0 and pi. But I didn't have theta, I wanted x. So 2x is 0 and 2x is pi. So I get, when I solve those, 0 and pi over 2. Do the same thing here. Subtract 1. Divide by 2, this 2. So again, I'm going to think of this as cosine theta equals negative 1/2. So cosine is adjacent over hypotenuse, so that's going to be pi over 3. But negative cosine is in the 2nd and 3rd quadrant, so 2 pi over 3 and 4 pi over 3. But I didn't have theta, I had 2x. Well, I don't want to divide by 2 when I already have a fraction, so I'm going to multiply by 1/2. So x is pi over 3, And here, 2 pi over 3. On to E. 2 sine of 3x equals 1. I'm going to divide both sides by 2. And I'm going to do that same strategy with the theta replacement. Sine of theta is 1/2. So opposite of 1 is the pi over 6. But I also need the other quadrant that sine is positive in, and that's 5 pi over 6. But both of those are really equal to 3x. So I'm going to multiply both sides by 1/3 to eliminate the 3. So here I get pi over 16. No, it's 18, sorry. And 5 pi over 18. Let's see, is that right? Oh, but then I gotta get all the other angles. Oh, I should have done that for the others too. Oh, sugar. How far back do I have to go? See, I should have been checking my work all along. So back here for D, sorry about that with the 2's. The 0 and the pi over 2, but then I need every pi over 2 rotation to get the, I don't know what I'm saying. Hang on, give me a second to collect my thoughts. Okay, it'll be easier to explain with the 1/2 one, then I'll go back to the 0. So over here with the 1/2, the negative 1/2, I need the pi over 3, but everywhere that cosine is negative. So that's this, no, that's positive. This quadrant and this quadrant. So this quadrant would give me also 4 pi over 3. And then the last quadrant would give me 5 pi over 3. So what you could do is check, if you substitute this back in, that's going to give me cosine of 10 pi over 3. So cosine of pi over 3, that's the 1/2, but then 10/3, well, where is that? 10, that's 4 pi over 3, which is down here, so that's why it's negative. So we have to include all these values. So the same thing, the same idea over here, we're also going to have to include 3 pi over 2 and pi. Oops, that's supposed to be a 2. So then back to this one with the 18ths. So we've got pi over 18, 5 pi over 18, and then all over the 18 is, then we're going to get 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. So what happens is each answer is going to give me 3 angles. So that's why there's 6 answers total. Okay, last but not least for F. I don't even know where my questions are anymore. Here we go, F. Okay, back in focus. 3 tangent of 2x plus root 3 equals 0. I'm going to isolate the tangent of 2x. So that's negative root 3 over 3. I'm going to think of that as negative 1 over root 3, as if we had not rationalized the denominator. And I go over here to my picture. Tangent is opposite, so I want opposite, so that's pi over 6. So 2x is going to be something pi over 6. So tangent is negative, in the second and fourth quadrant. So 5 pi over 6 and 11 pi over 6. So I'm going to multiply both sides by a half. Like times a half puts that in the denominator, so that's where I'm getting the 12 from. So then I have to get 2 more angles. So to get them, I need 17 pi over 12 and 23 pi over 12. All right, that is the end of the second test review. There is one more to go. Okay, in the second test review, I didn't do a great job explaining why we have all those extra answers when we solve and there's multiple angles. So if we look back at number 8D, what happens is we solve down after factoring and we got sine of 2x is 0 and then cosine of 2x is negative a half. So let me explain this in a different way. Our answers wanted to be between 0 and 2 pi. But now that it's 2x, if I multiply these, we get from 0 to 4 pi. So when we go to solve this, I want to know, okay, what angle gives me 0? So if I think of it as like sine of theta is 0. So theta, or 2x, would be, so where is the y coordinate 0 is at 0 and pi. But I need to go all the way to 4 pi. So then I'm going to go around again to 2 pi, because that's, I wish I had that picture over here. So here and here. So we've got 0, pi, 2 pi, 3 pi, and I'm going to stop because I don't want to include 4 pi if I go back. But that's 2x equals that. So I'm going to divide everything by 2. So x is 0, pi over 2, pi, and 3 pi over 2. So in the answers, that's how we get these first all over 2's. So now I'm going to do the same thing with cosine and then negative 1/2. I'm going to think, when is cosine of theta negative a half? So going back to my triangles, oh look, that was nice. Cosine is pi over 3. But then negative puts me in the second quadrant and the fourth quadrant. But I have to go all the way to 4 pi. So I need more angles. So here's how we're going to get them. I want to go, they're all going to be over 3. So where's my, so here's 2 pi over 3. And then if I go around again, so plus 2 pi, ready for it? 2/3 plus 2 is 8/3. So that's 8 pi over 3. And then I'm going to take the 4/3 and go around the circle. That's 10 over 3. But these aren't my answers. I have to divide everything by 2, which is like multiplying by a half. So 2 pi over 3 times a half gives me pi over 3, because the 2's eliminate. 4 pi over 3 times a half gives me 2 pi over 3. This is such a better, much more thorough explanation than the other video, I'm sorry. 8 pi over 3 times a half gives me 4 pi over 3, and then 10 pi over 3 times a half gives me 5 pi over 3. So these are the cosine answers, and then we had these 4 answers from the sine, and that's how we get these other answers here. It's the same logic for E and F. How much time? Okay, let's see, where's my E? E, we got down to sine of 3x is a half. So 3x is going to equal, or the angle is going to equal, well, where is sine positive a half? That's pi over 6, and I'll put this one over here, 5 pi over 6. But if our original answers, oops, had to go from 0 to 2 pi, I have to triple this, because it's 3x, to make this 6 pi. So I need to add 2 pi to both of these until we get to 6 pi. So I'm going to do 1/6 plus 2 pi. That gets me 13 pi over 6. That's just a little more than 2. So then I'm going to add another 2. That gets me 25 pi over 6. Then for the 5/6 plus 2, 17 pi over 6, and we'll do one more rotation because it's 3 times, 29 pi over 6. But all of these were 3x, so I have to multiply everything by 1/3 to get my final answers. So that's why, if you look at our answers, we get pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25, and 29 pi over 18. So I hope that was more clear. I'm going to link this video to that first one.